With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. The question says that which of the following is are correct regarding the radius, and we have been given here options, and in options we have cations as well as anions also arranged in an order, so we have to find out the correct order of their radii, right? So firstly we should know that the general trend is that in case of cations, right, I'm firstly writing down the general trend is that as the charge on the cation increases, right, as the charge on the cation increases, atomic radii or the ionic radii it decreases. And for anions it is that as the charge on an anion increases, so its atomic or the ionic radii it also increases. So this is your general trend which is followed and which is also correct in most of the cases. So if I look according to this particular explanation, then this option number 1, and we look at option number 2 here, so option number 2 will be correct according to this explanation which I just said, and option number 3 will also be correct because in option number 2 the smaller is the size of the cation, lithium plus should be greater because of the less charge it is carrying, and then we have beryllium plus 2 and beryllium plus 3. And in option number 3 here we look, all the anions have been arranged in the increasing order of their charge, because I just said that as the charge increases the radii should also increase, but then both these options are incorrect actually. Here what we need to also notice and remember is that whenever we have to decide the atomic radii of the charged species, cations or anions, we have to also consider the electronic configuration, otherwise the answer would come out incorrect. So if you look at option number, so both these options as I said are incorrect, and option number 2 in itself is incorrect because here it is showing that as I said, so all these 3 options are incorrect, right? So for option number 4 actually the correct reason, let me just write down, we have B3 plus, gallium 3 plus and aluminium 3 plus. So we have boron, then we have aluminium, then we have gallium. So what is common between all these 3 elements is that all of them belong to group number 13, that is they belong to the same group, and we know that as we move from top to bottom in a group the atomic radii increases because of the increase in the number of shells. But out of aluminium and gallium, what is important to understand is that the size of gallium is in fact less than the size of aluminium. Now why it is so? So this is an exception here, that the size of gallium is less than aluminium. The reason being is that if you look at the electronic configuration of aluminium and gallium, is that in gallium, since the electron first time enters into the d subshell, right, so since the electron is first time entering into the d subshell, this result that the atomic size of the atom contracts. So atomic size of the atom contracts, right? So because of this contraction the size of gallium, which should have been greater than aluminium, decreases, and this is an exception. So this means if you look at option number 4 here, so it is suggesting that we have B3 plus, then the size of gallium is greater, and out of all these 3, aluminium plus 3 has a greater ionic size than boron and gallium. So this means that option number 4 is your correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.